So today I'd like to give an introduction to the Sage Cloud server. And so this is just an introduction if you've never used it before at all. So let's just start, say, at Google trying to find the Sage Cloud server. And so let's type in SageMathCloud. Okay, there it is. And click on that. And when you first arrive to Sage, then you'll have to create an account. I already have an account, so I'll just go ahead and sign in. After you have signed in already, then you will end up at a page like this listing all of your projects. And so if you don't have any projects, you'll just see a blank screen, and then you click Create a New Project. So let's just create a new project here, and let's call it Learning Sage. And in the description doesn't really matter, just for your own purposes. Let's just say we learn Sage here. Okay. So we create the project. There's a little window that shows up here whenever something changes, create a new project. Okay. So we go in here, and there should be no files in here since we just created an empty project. But we can create some new files to create new Sage files and do things within Sage. So let's create a new file. And so the create new file page looks like this. Let's create a file called one intro to Sage. And then if you just hit enter, it's just going to create a generic file. And so we want to create a specific type of file. We want to create a Sage file. Of course, you could do all kinds of things. You could create LaTeX, Jupyter, whatever other types of files you want, any particular file from a dropdown. Let's create a Sage file itself. Okay. So let's make a Sage file. And so a Sage file is just essentially like a workbook of code that we can use to run and do various manipulations. And so let's just start out with a simple calculation, mathematical calculation we might want to do in Sage, 2 times 3. And so on line 1, we'll just enter 2 times 3. And to evaluate the cell to see what 2 times 3 is, you hit Shift-Enter, and then it returns a value that 2 times 3 is 6. Within Sage, you have to use the asterisk for multiplication. In some other systems, sometimes you can use a space, and that's inferred to be multiplication. Not so in Sage, it gives you an error message. So you really do have to use the star in order to show that you really want to multiply things. Okay, but that was a little too simple. What we really would like to do in Sage is maybe do some function definitions. So let's zoom in a little bit here and define a function. Say f of x is x squared. We hit Shift-Enter. And then nothing really shows up here, mostly because now Sage just knows in its memory that f of x is x squared. If you want to know what f of x is later, it's x squared, so it's just kind of stored in your memory already. If you want to know what a particular value of that function is, f at the value of x equal to 2, well, that's 4. Okay. You can also show these functions in fancy form rather than having these carets as we have here. So one way to do that is to say show f of x if you want to actually see this in a little bit more nice of a form. If you say show f of x, then you see it kind of types that a little bit nicer as x squared here. Okay, so that's a basic function. You may have noticed these gray bars that show up here. These are the bars separating the different cells within Sage. So if, for instance, I wanted to insert something in between this cell and this cell, I could just click on that bar, and now I can do something here. Now I can do f of 4 and get a new result. And so you can click those bars to insert things. Also, if you, instead of hitting Shift-Enter, if you just keep hitting Enter, it just adds more lines to your cell. And so you can add lines to your cell, do multiple things all at the same time if you want. So that's certainly possible as well. Let me hit delete and get rid of that extra cell. Okay, so that's basic functions. Let's just see what it thinks x is. Okay, so it thinks x is x, just a variable. What does Sage think another variable might be, like z? Well, if you ask it that question, you get some nasty error message like this. And in particular, generally on these error messages, the last line is the one that's most important. Z is not defined. We haven't defined z to be a variable here. And so it doesn't know what we're talking about when we're talking about z. Instead, what we need to do is we need to define it as a variable. X was defined as a variable because we said we're going to define a function f of x, and Sage already thought, okay, you want to define f of x, x must be a variable, and so I'll do that for you. Instead, we need to do something to call this a variable. And so one way to do that is this form, just to call z a variable that we're not really going to do anything with, var of z, and the z has to be in quotation marks. So that's one way to define a variable z. Similarly, t is not yet a variable, but I could define t to be a variable as well, and let's do this using another way of defining a variable. This is a rather strange looking way of defining a variable, but it will also work. And so now if you ask what t is, oh, t is also a variable. The first line you saw output z back again. The second line did not output t back again. So when I asked it later if t was a variable, yes, it was. Okay, so let's do some algebra with this. Let's look at z minus 2 squared. Okay, yes, that's z minus 2 squared. But let's say that we want to expand z minus 2 squared. Okay, so you just ask it to expand that, and then it expands out that polynomial. You could also factor a complicated looking polynomial. And so let's say we factor, and well, you probably have an idea of what this is going to factor to be. Indeed, it's z plus 1 cubed. Okay. Sage will generally do some simplification for you. And so if I look at this combination, for instance, and I evaluate it, it will expand some of these things out to make it as simple as possible. Sometimes you have to force it to expand, and sometimes you don't, depending on how compact the expression might look if you expand or not. Okay, let's talk about some other types of things you can do with Sage. You can do algebra, yes, but you can also do calculus. And so let's ask Sage to integrate f. And whenever we ask it to integrate, we have to tell it what we want to integrate with respect to. And so if we say integrate f of x with respect to x, it performs an indefinite integral here on f of x. There's actually multiple ways of doing integrating. You could integrate, or you can do integral of f of x with respect to x. Either one works, and so you don't have to be particularly precise about that. If you want to put limits, so you turn your indefinite integral into a definite integral, well, you can do that. So let's integrate f of x, and now let's say x from 0 to 3. And now it spits out our answer for the integral from x from 0 to 3. There's another way of imposing the integral method within Sage. One way you could do it, which will be useful later when we do commands that look like this, is to insert integrate with respect to this. So f of x, you want to integrate f of x with respect to x, and then it returns the same result. Let's talk a little bit about how numbers work in Sage. So Sage knows about certain numbers. For instance, it knows about pi. And so when you ask it what pi is, it just spits back pi rather than saying that there's an error. It doesn't know what this variable is. If you want the numerical value of that value of pi, you can ask it n of pi. It'll give you a numerical value to some predetermined amount of precision. Okay, you could also ask for the numerical value of e. It will also spit that out. Say you want pi to a certain number of digits. Well, you can say n of pi, and then say, I want the number of digits to be equal to, say, 20 digits. Okay, now it'll spit out pi to 20 digits. Say you integrate something. So we integrate, say, e to the x squared from x from 0 to 1. And the answer you get is not particularly enlightening. Maybe something like this. And here this involves then the arrow function. Well, we can numerically evaluate this integral by just putting that n, or the integrate inside of n, and it'll numerically evaluate the result for us so that we can get maybe something out of this. Sometimes that expression is useful. In this case, maybe not so much. To remind ourselves what f of x was, so f of x is x squared, not only can we integrate f of x, we can differentiate f of x. And so if you say diff f of x, well, it knows what you mean. It knows that you want to take a derivative of that. You could also take derivative of f of x, just like integral, integrate. That also works. When you take diff or derivative with respect to f of x, since it's only defined with respect to the x variable, it just automatically takes the derivative with respect to x. If you want to be sure that you're taking a derivative with respect to the correct variable, you can always put comma x, and then it takes a derivative with respect to x. In particular, if you have a function of two variables, so x squared y, for instance, you can take the derivative of that function with respect to x, or you could take the derivative of that function with respect to y. And so it matters which one you do, obviously, and so you can implement that by putting comma x, comma y. Lastly, let's talk a little bit about the basics of vectors and matrices. So if you want to define a vector, then let's just say v is equal to some vector. And so how we define a vector is inside of the curly braces, we put square braces and then our indices. So I'll let v be a two-dimensional vector, and so it's 1, 1. Let me define another one. Let me define u to be a vector 1, -1. Okay, and so now these are vectors inside of Sage. I can take various operations on these vectors. I can add them. I can subtract them. I can multiply them. And I get 0. I can multiply it with itself to get its magnitude squared. I can also find the norm of the vector. Okay, so I can do the usual operations on vectors that I might like to do of dot products and taking the norm, and those are all kind of built in. So if you define it as a vector, you don't have to do anything special. You just multiply the vectors like you normally would. If you want to define a matrix, you can define it in a similar way. Say you have to tell Sage you want to now define a matrix. And so let me define a 2 by 2 matrix. And so I put my first column, or my first row, and my next row. And so now now A is a matrix, 1, 2, 3, 4. And I can do similar things with matrices. In particular, let me find the determinant of a matrix, and the determinant of this matrix is -2. So that gives you a basic introduction to some of the primary features of Sage. In other videos, we'll explore many of the other features that you can do.